All right, today we're going to continue with trig identities, and we're going to talk about sum and difference identities. So we use these when we are trying to find a sine value or a cosine value of an angle measure that is not on the unit circle. So for example, for number one, this first example in red, if I asked you to find the sine value of 75 degrees, well, we can't find that because it's not on our unit circle. However, we can find two angle measures that add up to give us 75 degrees from the unit circle. So for example, if I said, okay, well, what about then the sine of, let's see, that'd be 45 degrees, which is on the unit circle, plus 30 degrees, which is on the unit circle. Well, 45 plus 30 is 75, so this works. Okay, but now what do? I'm going to have to look ahead and plug it into this top formula where I take my first value represented by alpha, first letter in the Greek alphabet, plus my second value represented by beta, the second letter in the Greek alphabet. And I'm going to follow this formula. So notice I'll need sine and cosine of both 45 degrees and 30 degrees. So what would be helpful is going to our unit circle and recognizing, okay, so 45 degrees, if I look on my unit circle, that's radical 2 over 2, comma, radical 2 over 2. And then if I go to 30 degrees on my unit circle, we have radical 3 over 2, comma, 1/2. And so writing those down so you don't mix up any positives or negatives that might happen in other quadrants would be helpful. So now I'm just going to follow the pattern. So remember, it's always x comma y or cosine comma sine. So don't forget that here's my cosine value, here's my sine value. And we'll need that for the formula. So what is the formula? Sine of alpha, or sine of my first term, which is 45 degrees. So therefore, we're going to say sine of the y value at 45 degrees, which is radical 2 over 2. Sorry, I did not mean to write sine there. So what is the sine of 45 degrees? Well, it is radical 2 over 2. So radical 2 over 2 times my cosine, the x value of beta, my second value, which is 30. So what is the x value of 30 degrees? Well, that is radical 3 over 2. So radical 3 over 2. Following the formula, plus sine of beta. So the y value of my second term, which is 30 degrees. So y value of 30 degrees is 1/2. Or the sine of 30 is 1/2. Times cosine, the x value of my first angle measure, 45 degrees. So if I go to 45 degrees, my x value, my cosine, is radical 2 over 2. So again, just trying to follow a formula. Now, we need to multiply. Multiply fractions, we multiply straight across the top, straight across the bottom. So we're going to do that for both of these. And when I do that, radical 2 times radical 3 is radical 6. So radical 6 over 4 plus 1 times radical 2 is radical 2 over 4. Now, we have common denominators, so we can combine these. When I combine them, though, I cannot add a square root of 6 plus a square root of 2. So those cannot be added, but they have this common denominator of 4. So this is the sine, the exact value of sine of 75 degrees. Now, let's do one more. What happens if we need to subtract to get these two angle measures, meaning we're going to have to use this second problem or second formula. So what are two numbers that subtract from the unit circle to give us this sine of 15 degrees? And so what we could say is, I need the sine of 45 degrees minus 30 degrees. Both of those are on the unit circle, and both of those will subtract to get us 15 degrees. So we're using the same coordinate points. So radical 2 over 2, comma, radical 2 over 2 for 45 degrees. And then at 30 degrees, we have radical 3 over 2, comma, 1/2. And from here, remember, we have x comma y, or cosine comma sine. And so we're going to need to remember that for these. So x comma y, cosine comma sine. All right, so now, how do we follow this formula in the blue? So the sine, or the y value, of my first angle, which is 45 degrees. So the y value at 45 is radical 2 over 2, times the cosine, the x value, of my second angle measure, 30 degrees. So the x value of 30 degrees is radical 3 over 2. Minus, so notice the minus sign because of our minus in our formula, minus the sine value of our second angle measure, so the y value of 30 degrees, which is 1/2, times the cosine or the x value of our first angle measure, which is 45 degrees, so that is radical 2 over 2. So let's go ahead and plug this in, and we get, again, multiplying straight across the top, straight across the bottom for fractions. So we get the square root of 6 over 4 minus, so it's a little bit different, the square root of 2 over 4. And just in the same way, we have these common denominators, so go ahead and combine those. It's trying to add or subtract a square root of 6 with a square root of 2 is trying to add or subtract an x with a y. You just can't do it. They're not alike, and so we have to just write them side by side. But we do have a common denominator, so this is the exact value of sine of 15 degrees.